I'm Nikolay, and today we're going to talk about delay accounting. My talk is I call it the underrated feature of the Linux kernel. So let's start. A few words about me. I'm initially an admin ops guy, so I'm more about running production systems rather than developing and writing code. And I'm former head of infra in pretty big company. And then I decided to go to entrepreneurship journey. And now I'm working on Coroot. It's an open source observability platform. Um, you can check our repo on GitHub. So let's start talk about CPU. But before we start, let's talk about multitasking. What is multitasking? Multitasking is the ability of operating system run several processes simultaneously. In fact, we have a limited set of CPU core and many tasks. And we need to somehow distribute these tasks among our CPU cores and share the CPU cores across them. And in Linux, the default scheduler called completely fair scheduler, it takes many factors into account while distributing processes across available CPU cores. It can take into account some weights like CPU shares. It can limit some processes and CPU time if a user defined a CPU limit and so on. But now let's talk more about how it happens. But I prefer to start from a big picture. If you think about CPU as a administrator of a node, we have some number of CPU cores, and we have processes that are ready to execute on some of them. So, and our main goal is to give enough CPU time to every process. So we have some queue, scheduling queue, and limited number of processes that executed right now, that's equal the number of available CPUs on this node. But from our perspective, we don't care about the amount of CPU on node. We just need to have enough CPU time for executing our code, and that's why it's super for applications. It's super important to get their CPU time as soon as possible, because if we spend some time in the scheduling queue, it will add latency to our application performance. Like if we, for example, execute our code 100 milliseconds, but before that we waited for 50 milliseconds in queue, the total latency will be 150 milliseconds. And if we're talking about CPU monitoring or troubleshooting CPU-related tasks, we have pretty popular metrics, CPU-related metrics. Let's take a look at them. First one is load average. We will discuss it closer. Node CPU usage and container CPU usage. Load average is a pretty pretty common parameter. You can see these three magic numbers in output of the utility top. And it's literally the length of scheduling queue. For example, in our case, we have 16 processes waiting for a CPU time, and in our case, load average at this particular moment of time is 16. So it doesn't reflect any times or latency, how long we we spend our process spent in that queue. So it's like this metric doesn't answer our question initial, how long our application waited for a CPU time. Node CPU usage is the percent of time each or all our CPU cores executed some code. It's not related to our particular application. It's just saturation of our CPU resource. So CPU usage at 100% can be good and bad at the same time. It depends on how it affected performance of our application. That's why this metric itself also doesn't answer our question. Container CPU usage or application process CPU usage is the amount of time each application actually ran on the CPU. So, for example, if we see container CPU usage at 200 milliseconds, it means that during a second, 200 milliseconds per second. And it means that it's like it consumed like 1/5 of the CPU core. So it's good to know, but this metric also doesn't answer our question. What we really need to know is how long each application spent waiting for CPU time. Why it's important? It is important because when we troubleshoot application latency, that's only this metric can answer, do we face any CPU-related issues or not? For example, if we look at just CPU usage or load average or container CPU usage, we can be sure that there were like our latency degradation is related to any problem related to CPU. And with like this metric, potentially with this metric, we can precisely detect that our process experienced a lack of CPU time. And potentially we can understand that if we add more CPU time, we can drastically, or not drastically, we can just reduce our application latency. And using this metric, we can distinguish scenarios where 100% CPU usage of a node doesn't really affect our application performance. And such a metric exists in Linux. It's called delay accounting. The Linux kernel calculates for each process or even thread, POSIX thread, how long each thread has been waiting for a CPU time while being runnable. It's super important because it doesn't include the time where process executed some I/O or something like that. And it also can show some statistics about non-CPU and other resources, like how long the process has been waited for memory reclaim or swapping pages. And but the problem is that this metric is not exposed to the user space, and it can be the like monitoring agent or other process can access this metric through task-stats. Task-stats is a netlink-based interface communicating with the kernel, and we can ask the kernel, like established special netlink socket, and ask the kernel about all processes or the particular process. And you can get these counters and use it like for monitoring and so on. Also, additionally, the pretty same statistics is accessible through procfs. Each process ID has a dedicated shared stats file, and you can access the numbers, and you also can the second parameter is time in nanoseconds that this particular process spent waiting for in a run queue. And we implemented in our open source Prometheus compatible exporter, we implemented gathering CPU delay, so you can just install it and you will have these metrics in your Prometheus easily. And let's take a look at the metric itself. So we have a metric called container resource delay, CPU delay seconds total. It means if you want to understand the amount of CPU delay in each particular moment of time, we should use function rate. And here we have chart reflecting this metric for our Docker container. And here we can see the two spikes. The first one is 1.2 seconds per second, means every second the application had additional latency at more than 1 second. And the second spike, like 800 milliseconds. And we can see that in these time ranges, we haven't had any issues with CPU. So our application or container didn't experience any CPU related issues. And also I had two examples. The first one is when we run our application and something and like some CPU noisy neighbor on the same node. And you can also, in Linux scheduler, you can also configure CPU shares and give some processes low or high CPU priority. In this scenario, I run the stress tool with low CPU priority, and we can see that it caused a CPU delay of our application like less than 300 milliseconds, and it didn't affect our application latency. But the CPU usage of the node were stopped 100%. And in another case, we also have CPU stress application run on the same node. CPU usage is 100%, but it caused delay more than 1 second per second, and it affected application latency because I run this app stress application with higher CPU priority. And using CPU delay, we can measure how lack of CPU time affected our application. And like few words about what can cause high CPU delay. The first one is like not CPU capacity, because processes or containers run on the same node, compete for CPU time, and if we are out of available CPU time, any container can experience the lack of CPU time or CPU delay. In another scenario, a container consumed all available CPU time on the node on its own. In this case, we can only scale our node and provide our application with more CPU time. Or if we define CPU limit for our application, and if it hits CPU limit, the Linux kernel will throttle or limit it with the CPU time for a while. So we have, like, if we detected that we encounter CPU related problem for our application, we can investigate these reasons closer and find the root cause. And final thoughts is that our current CPU-related metrics are not good enough for troubleshooting CPU-related issues. I believe we should start with metrics such as CPU delay or we have pretty close metrics by meaning. And then we should go deeper and understand why it's happened. But CPU delay is right metric to start any troubleshooting if we have a hypothesis about that our process experienced a lack of CPU time. So that's it. If you have any questions, I would love to answer.